Hello everyone, in this video I'm going to go through the AQA Combined Science 2022 Physics Paper 1 Higher Tier. This is question number 2, which the first section is actually questioning on energy. So a student made measurements to determine the specific heat capacity of vegetable oil. Describe how the student could use the equipment shown in figure 2 to determine the specific heat capacity of vegetable oil. So in order to determine the specific heat capacity, the main equation that you need to know and remember is this equation: E equals mc delta theta. That should look like a triangle. Get rid of that. Be delta theta. Now if you rearrange it, well, this is energy. E is for energy transferred, m is for the mass, C is for specific heat capacity, and delta theta is the temperature change. So to find specific heat capacity, you would need to know the energy transferred divided by the mass of the substance or material multiplied by this temperature change. So how would you do this? You've got a joule meter which will measure the energy, and the thermometer is used to measure the temperature change, and the top band balance is to measure the mass. Now the heater is what's going to supply the energy. So what you would do is place the beaker on top of the electric heater and press and add a known mass of oil, right? And then you would heat it for, let's say, 5 minutes, and then find the temperature change. What is the initial temperature and the final temperature after 5 minutes of heating? So you'd find the maximum temperature change, and you would use it in this equation to find the specific heat capacity. So how do we write this answer? So for 6 mark, this is a 6 mark question. You need to describe how the student could use the equipment shown in figure 2 to determine the specific heat capacity of vegetable oil. So you want to make sure that you are referring to the equipment and why you're using it. Measure the mass of oil using the top pan balance. Now I referred to as top pan balance because they have referred to as the top pan balance. You can also refer to as the weighing scale. It's fine. Second point, measure the starting temperature of oil using the thermometer. Place beaker of oil in the heater and switch on the heater to heat the oil. Heat oil for 5 minutes and stir continuously. Now, why am I doing it for 5 minutes? The time doesn't actually, is not very important here. You can heat it for whatever time, but I'm just giving a set time. Measure the final temperature of oil using the thermometer. You could say measure the final highest temperature as well. Calculate the increase in temperature, which is delta theta, final minus the initial temperature. Measure and record the energy transferred using the joule meter. Use the equation E equals mc delta theta to determine the specific heat capacity, which is C equals E divided by m delta theta. Now, that should give you all the 6 marks for this. Now, if you were to draw the diagram, I would actually just draw that simple part. But if it wasn't an electric heater like this, in class, you would use something called an immersion heater. So a typical example of that setup is basically here. So here, that's your heating coil. You have insulating material to ensure that no heat is lost. So you would also want to add, you could add insulating material around this beaker as well. And here the power supply, the rheostat is to control the current in there. Question 2.2. Now this section is on the electricity topic. Give one risk when using the equipment in figure 2. Now one of the risks is the electric heater is obviously going to be hot. So you need to make sure that you are careful from that. So one of the risk is the burns or scalds. You could also say cuts from broken glass. Now you can't, if you say the heat or the oil is hot, right, that's not a risk. A different student did not have a joule meter and calculate the energy transferred by the electric heater. Use the physics equation sheet to answer questions 2.3 to 2.4. Write down the equation linking energy transferred, power, and time. Now the equation that links all three is this equation. Power equals energy divided by energy transferred divided by the time. So energy transferred divided by the time. Question 2.4. The electric heater had a power output of 50 watts. Calculate the time taken for the electric element to transfer 4,750 joules of energy to the vegetable oil. So P equals E divided by energy divided by the time. They're asking us to find the time. So rearrange. Time equals energy divided by the power. So 4,750 divided by 50. 4,750 divided by 50 equals 95 seconds. 95 seconds. Question 2 still continuing. In a deep fryer, vegetable oil is heated by an electric heating element. Food is then cooked in the hot vegetable oil. The deep fryer contains an electrical component to monitor the temperature of the vegetable oil. Figure 3 shows how the resistance of this component changes with temperature. So you have the temperature going from 0 to nearly 250, and the resistance starts at 1000 and it reduces nearly up to about less than 100. Question 2.5. What electrical component is used to measure the temperature of the vegetable oil? That would be a thermistor. Remember, thermistors have a symbol like this. Electrical symbol for a thermistor is that, and its temperature changes, its resistance changes with temperature. Question 2.6. The electric heating element in the deep fryer automatically switches off when the vegetable oil reaches a certain temperature. Figure 4 shows how the temperature of the vegetable oil changed after the deep fryer was switched on. So the temperature increased from about, that's 50, okay, so that's 10 boxes is 5, it's 25, so 20, it started about 20 and it went all the way up to about 160 and stayed the same. Determine the resistance of the electrical component when the electric heating element automatically switches off. When is it switching off? It's switching off when the temperature is 160. So that is 160 degrees Celsius. So you need to use the information from this graph and from the previous graph. So 160 is going to be, so that's over there. Let me change that. 160 is going to be there. And the corresponding resistance, so they're asking for determine the resistance of the electrical component. So the corresponding resistance would be, that's nearly that box. So that's somewhere there. So that should be, that's 300. So 240, between 240 to 260, I would say 250. So because this is 300. So over here, that's 300. So I would take the value in between. The resistance is 250 ohms. Question 2.7. This part is actually on the particle model of matter. Question 2.7. Some chips were put in the deep fryer. In the deep fryer, water in the chips underwent a physical change and became steam. Why is this a physical change? Now, there are two types of changes, physical and chemical changes. Remember, in a physical change, it's reversible. In a chemical change, it's irreversible. So, all water can change to steam. Now, no chemicals were involved when water changes to steam. The change from water to steam can be detected visually. Now, the water will recover its original properties if the steam was cooled. That what they're saying is that it can be reversed. That would be the answer. That brings us to end of question number 2. I will see you in question number 3.